Hello, everybody. Glad to see you all here. My name is Sergei Shulpuk, and today I'm gonna tell you about how to use AI coding tools better, efficiently, how these tools work, how they don't work, and what we can do about it. I'm sharing my screen with you right now. Right? Let's kick it off. So today, I'll briefly tell you a few words about these AI coding tools, why they are so popular these days. Things changed a lot of the last, say, 12 months. Today, they are very different tools as compared to what we had in April 2025, for example. Then we'll briefly talk about the AI agents. That's the foundation of those tools. Also, how we can make our life in engineering better with these tools and how not to. We will say a few words about the problems that these tools possess and also how to resolve those problems. And also we'll share a couple of best practices that we internally use and that help us with making those tools more efficient for us. In the end of this presentation, in the end of this webinar, you'll have a chance to schedule an AI consultation with us, with me particularly. So if you have any questions that is still there after the webinar, please reach out to our engagement team and they will schedule a conversation. Also, please do use the Q&A section of the webinar tool of Zoom. That will enable you with asking questions, which we will answer in the end of the webinar. And having this, I'm ready to move on. A few words about me. I've been working with AI since the slide says 2013, but that would be the official positions, stuff like that. Overall, it's been since 2011, so roughly 15 years by now. I've built the AI businesses and service lines for 3 companies. I've been building my own startups, raised money in the US, raised money in Europe, got European grants. I helped raise 52.5 million in stage B funding for a startup where I've been a vice president of data science, and so on and so forth. So I've been around for quite a while, and I've been witnessing the field, how it develops, how it changes over the last decade and a half, long before the ChatGPT hype, even slightly before the previous hype of 2012 ImageNet competition. So today I'm going to tell you interesting insights that those who have been around know, and those who haven't probably could find curious and interesting, with the practical perspective in particular. And a few words about Advantis. The company has been around for more than 20 years. We have more than 400 engineers working for more than 40 clients, customers around the globe, and delivering more than 450 projects over the course of those 20 years. Over the last 2.5, 3 years, we've been very active in the field of AI, particularly generative AI, and we've been doing a lot with respect to building RAG systems, agentic systems, deploying them in production, training, fine-tuning large language models, doing all kind of stuff that AI allows us to do today. And before we proceed to the substance, we'd like to start with a couple of questions so that I can adjust and calibrate my narrative better. The first question that I'd like you to answer is about your own experience with AI coding tools. We have quite a few of them around, and out of these tools, which one are you using? Which one have you been using? Which of these tools you have practical experience with, you or your team, obviously. Please take a couple of seconds to check all the boxes, assuming you could, well, you could be familiar with all of them, perhaps. And I guess that should be enough time for us, and I will ask the team to show me the outcomes. So Claude Code is predictably the leader. 71% of the attendees were familiar, are familiar, have been using or are using Claude Code. Super. Interestingly, GitHub Copilot is the second best, so it comes second, which is interesting. GitHub Copilot has been probably the first tool on the market, and they still obviously have a large market share. Others are at the third place. Actually, they are at the same. The others option got the same 43% as GitHub Copilot. So, well, probably there are more tools out there that you can put on one single slide. Interestingly, Codex only got 7%. So people, at least the present audience, are not very fond of Codex, let's say this way, but we'll say a few words about that later. Super. So we know that we mostly have experience with Claude Code and GitHub Copilot. We'll take that into account for today's presentation. And the next question that we need to calibrate the presentation, to calibrate the information, goes like that. Have you measured the actual productivity impact of AI coding tools on your team? Well, there's a lot of talks about how these tools change the development and engineering, and they definitely do. Obviously, it would be nice to know if you have any tangible numbers, if you've been, measuring or managing this impact across your company and your team. Now we have much less checkboxes, so hopefully we'll be over sooner than with AI coding tools. And now, thank you very much, my dear colleagues and friends, for arranging the poll. Please show me the results. All right, so we have 57% of the attendees, or at least those who voted, who said no, but we want to, which is perfectly fine. That's where we are all standing these days. And the second best is yes, but results are fuzzy. Interestingly, not a single person voted for yes with clear metrics, which kind of tells us a lot about where we are standing regarding the impact of the AI coding tools, but maybe also about the measuring development productivities in general. All right. Then let's jump to the substance. Now, I'll be a little bit hasty. We have lots of ground to cover, and I'll be doing a little bit of this drawing, and yeah, this kind of drawing. I'm a bad artist, so it's going to be a very contemporary drawing. Okay, where we are standing regarding all those AI coding tools, we would argue that in 2025, we firmly entered the agentic era. By agentic era, we mean the tools that could actually change the code or any other artifacts that we are dealing with. Prior to that, pretty much since the ChatGPT moment in November, or was that basically the end of 2022, I guess? We've been in the assistant era. Assistant era was the moment when we were using all those AI tools, but mostly in the autocomplete mode. So we've been mostly writing the code ourselves. We've been working pretty much at the low level of abstraction as software engineers, but these tools were already there and they were already useful, primarily at the autocomplete level. And prior to that, IDEs also had some of the AI capabilities. Some of them had autocompletes. Some of them used let's call it conventional AI, machine learning for indexing, for other things, but that was prior to Gen AI stuff. AI has been around in software engineering and in the tools such as IDEs for quite a while, for 10 years at the very least, but the technologies have been used for various different purposes. So since we are in the agentic era, meaning we trust these tools to actually make changes in our code base on our behalf, that's what we are going to focusing today. If we arrange the most popular tools at the two axes, where on the horizontal axis we would have the operational impact, which is from low to high, and on the vertical axis we will have the integration of the tool, meaning whether the tool is the IDE dependent, whether the tool is a part of the IDE, or whether the tool is a standalone one. Then we would have a very interesting map. On this map, we have this lower left quadrant, where we were having and we still have those tools which are integrated into the IDE firmly. That would go, for example, with the JetBrains AI. JetBrains is a wonderful IDE company. They have lots of IDEs. They have their own problems, but with respect to indexing, they are among the best. And also they have this JetBrains AI, which is tightly integrated with the IDE. You can't use it alone. You can't use it outside of the IDE. Same goes for GitHub Copilot, which today has the CLI mode, interestingly, which would put it somewhere like here. So I'd say that GitHub, I'm also not very good at handwriting, as you can see, but the CLI tools, which are not tightly integrated with the IDEs, would go somewhere around here, meaning they are not tightly coupled with the IDE, and you can use them in interesting setups, which I'm going to talk about in a minute. Now, at the standalone level, so they're not tightly integrated, but the operational impact is still limited, would be ad hoc Gen AI applications for the software engineering, such as asking ChatGPT to write a function for you, or asking, say, Claude to debug an interesting infrastructure failure for you. So that would go in here. They are these prompts and conversations, that's just one of the examples, right? They're not tightly coupled with the IDE. You can run them standalone, but the operational impact is still limited primarily because well, you still need to introduce those edits manually. On the bottom right, we have tools which have the high operational impact, but they're still IDE dependent. Here we would see cursor, and that's not the cursor CLI. We have cursor CLI in here, right? Most of these tools now are in the CLI mode, and that's something that you would notice, right? That was the development of those tools. So first we had cursor, and then we had cursor CLI. First we had Gemini Code Assist, which was tightly integrated with the IDE, and then we had Gemini CLI. We still have Windsurf, to my best knowledge, which is the tightly coupled with its own IDE, but things are moving very fast these days. I wouldn't be surprised if Windsurf is available as a CLI tool as well. So that gives us an interesting dynamics for the AI coding tools, which often started as tightly coupled IDE components and then evolved into this CLI. Some of those tools which started as independent as CLI at the very beginning was Claude Code and Codex. Claude Code is the coding product of Anthropic, and Codex is the coding product from OpenAI. Claude Code is the closed code product, although with the recent leak, it's arguable. You probably heard that Claude Code, Codebase has been leaked via a very sort of interesting, curious exercise, let's call it this way. You will read through that if you're interested later. But Codex has been open source from the very beginning. So Codex is the open source project of OpenAI, and Codex and Claude Code, they are pretty much the same in terms of how you interact with them. So these CLI tools, they have two interesting things in common. First, you can apply them or install them or use them with any IDE of your choice. Getting back to JetBrains, JetBrains have, say, or the company has, say, PyCharm. PyCharm is slow and using it is sometimes painful, but granted, they have the best Python indexing out there. There's nothing out there that could index large Python monorepos better than PyCharm. And if you don't like JetBrains AI, or if you want to use something else with your PyCharm, you can use any CLI tool with PyCharm. That's the power of those CLI tools. You can use the IDE of your choice, and then you can install the CLI tool or in plural tools to use with that IDE. You can even use Windsurf, which is an IDE, which is an AI IDE itself, with, say, Gemini CLI or Claude Code or Codex. You can have multiple CLI tools working with your project at once. So that's pretty cool. And these days, all the advanced tools are in the CLI mode. There's little, if any, tightly coupled IDE tools are still popular on the market. The best and the most popular tools on the market are the CLI tools today. So that's one development that we've been witnessing over the 2025, and today we are pretty much in the CLI era. Now, I need to tell you a few words about how those LLMs and agentic tools work, and that could be a little bit boring, but in order to explain, or tell you rather, how these tools fail, I need to explain you why. Because, well, if I just tell you, well, this is how they fail, well, would you believe me? Question mark. Let's start with why then. And to tell you a few words about the failure modes, I need to bring you back roughly in the year 2014, when we've been doing lots of conventional natural language processing, mostly funded by the marketing budgets. And the marketing budgets were huge back then. They are even larger today. And for the marketing, you are often interested in figuring out whether the social media tells good or bad thing about your product. So if you're a retail company, you can get all the tweets about your product by the hashtag that tags your company or your product. But then how do you tell whether that tweet is expressing a positive sentiment or negative sentiment about your product? This problem is known as sentiment analysis, and it's been fueling quietly, let's say this, the machine learning research for quite a while, because these companies and marketing budgets were spent not only on deploying those tools, but also on training those models. So roughly 12 years ago, if you were building the tool that could tell whether the tweet expresses a positive or a negative sentiment, you've been using likely something like a recurrent neural network. And you would be training a model that takes every individual word by word, as the input, and then it would produce the output as positive or negative. Obviously, the tool or the model wouldn't print out positive or negative for you. Instead, it would output either 1 or 0. So far, so good. But to train this model, you need a data set that would attribute the actual tweets to the positive or negative sentiment, meaning someone needs to sit down and actually label those tweets that you can scrap from the internet with the labels positive or negative. That's laborious. That takes time and money to pay for this work. So at some point, some people figured that if you first train your model to predict the next word, and then you use the same model, so you first train it to predict the next word, and then you, well, train it in the second run to predict the sentiment, meaning output 1 or 0, that works better. We don't know why. And often in machine learning, we first figure something out and then retrospectively explain why it works the way it works. I bet that was exactly this situation. Why this was important? Because, well, if you scrap lots of text from the web, then you can just predict the next word for as long as you like it. And you don't need labelers, right? Because the next word is already out there. This was the easy way to boost your sentiment analysis outcome without investing more money into labeling. So that was pretty cool. And people were using this approach with training first to predict the next word and then training to do the useful stuff, not only for sentiment analysis, but also for the document classification and all sorts of natural language processing stuff. Now, these half-baked models, if you will, that were just trained to predict the next word, and then you can do whatever you like with them, were known as the pre-training models or something like that. But at some point, they were just called labeled language models, and the name sticks. So some companies were just building those models and putting them out there for free, OpenAI being one of them. They've been just training the model to predict the next word and, well, just open sourcing this model so that you can do whatever you like with them. Actually, if you have the model that predicts the next word, then you can channel this word back as a part of the input and try to guess the next word, and then the next word, and then the next word. So that's how in theory, the language model works. Naturally, in practice, that is not as nice and beautiful. Now, in order to make the model that just predicts the next word a conversational model, you need to do a little bit more than that. That's something that OpenAI introduced in 2022 with ChatGPT. So the pre-training is exactly the same as we did in 2014. You have tons of internet data. You train your model to predict the next word out of all these tons of internet data, and you have the model that, well, can predict the next word. Then, the example of that model would be GPT-2. released in roughly 2019. And this is the actual output of GPT-2, which you can get out there. Again, it's open source, so you can, well, run this code on your own laptop and see what GPT-2 would do with the to be or not to be prompt. So this is what it does, right? To be or not to be, well, that's my typo, but it's still fun. That is to say to be or to be and to have been or be. So you see how it goes. Interestingly, if you take the local kind of window, if you will, then the local window kind of makes sense. And to have been, well, it's not a perfect English, but you could live with that, right? But if you read it through from the beginning till the very end, then you can notice immediately that this text doesn't make any sense. So that's pre-training. That's what you get in the end of the pre-training. Now, people are playing with these models a lot, and they noticed an interesting feature, if you will, of the model. If you start prompting this model with something like this, the capital of the United Kingdom is London, the capital of Germany is Berlin, the capital of France is, and then you ask the model to complete the text, then it goes like that. The capital of France is Paris, but the model doesn't stop here. It says the capital of the Netherlands is Amsterdam, the capital of Portugal is Lisbon, and so on and so forth. Again, this is the actual execution of the GPT-2 model. Well, as you can see, this is not a conversation at all, and this is not a question answering, but the model kind of knows something, right? It kind of knows that the Paris is the capital of France, and you can, well, maybe extract this answer out of this model. Again, that was roughly 2000 and maybe 19 or maybe 18, when we've been playing with all these interesting, fun stuff of the language models without knowing the consequences of the game. But these models are not assistants at all, right? For example, if you ask the question in the form of a question, what is the capital of France? Then you would see like this, what is the capital of France? Again, that's a real execution. This is what GPT-2 actually gives you for this question. So what is the capital of France? It is a city of 4 million people with more than 80 different provinces and territories, yada yada, the capital, Marseille. So you see it's rubbish, right? You can immediately spot that that doesn't make sense. I mean, locally, it is a city of 4 million people, yes, but is it a Paris? Question mark. But if you read through the entire sentence, then you see it's rubbish. Here, at this very moment, you would spot an interesting feature, an interesting problem of those large language models that we know as the bad token problem. You would spot a bad token if you look at the line number 3, where the model generates something about Paris. So the model says, and I'm getting rid of all this color. The capital is known as the French capital because of its importance to the French and the capital and so on and so forth. You see that's rubbish. First of all, Paris isn't known as the French capital. This is nonsense. But also, as soon as the model spits out the bad token, such as the phrase the capital is known as the French capital, it doesn't stop there. It tries to justify or make the bad token plausible by the rest of the sentence. So if you were, well, as a human being, if you were, for some reason, to say the capital is known as the French capital, you would maybe say, oh no, hold on, disregard, right? I didn't mean that. I mean something else. But language models don't do that. They just keep generating stuff to make the previous stuff look plausible. So if the model generates rubbish, such as the capital is known as the French capital, it keeps generating something that makes this, at least it tries to make this rubbish, less kind of, well, a little bit less severe, let's call it this way. And that doesn't really help because, again, if you say the capital is known as French capital because of its importance to the French and the capital is also home, yada, yada, that doesn't make things better. Arguably, that makes things worse. And this feature is still with us, although, you know, now we have the conversational models and so on, but this problem is still with us. And I'm getting a little bit ahead of myself, but for coding, the bad token problem manifests in the situation when your agent generates something which is completely unnecessary, like, say, the global variable that shouldn't be there, or, for example, the decorator that doesn't belong where it is stated. But since the model now wants to justify the bad token, it would use this global variable instead of deleting it, right? So when the global variable doesn't really need it, but the model puts it there like the French capital, it will actually figure out how to use this global variable. And that's the bad token problem, which we are going to touch slightly further down the presentation. Okay, good. So that's been pre-training and how pre-training affects your coding, coding kind of tools and agents today. At the second stage, we train the model to provide the actual answers because you've seen that the question, what is the capital of France, doesn't result in an answer. To do that, we train these models on the question-answer pairs. That's a question, that's an answer. And this text is a part of the actual dataset called Open Assistant Conversations dataset. It's open source, you can figure it out there. And what you can immediately spot here is that it is the question-answer pair, right? It is never a question-question pair. So whenever you train the model to always answer the question, you kind of push it into an interesting behavior. First of all, the model never asks clarification questions because, well, the model has never been trained on the question clarification question pair, only question answer pair, which means the model always answers your question, regardless of whether the question is well stated, whether the question is complete, whether the question is reasonable, whether the question could be answered at all, whereas the question is as ambiguous. All that is completely irrelevant. The model always provides the answer. And here is where the hallucinations are rooted, because if you always provide the answers, regardless of whether the question, provides you with enough context to answer the question, what happens if the question actually doesn't? What happens if the question is irrelevant or incomplete or ambiguous or well, just plain wrong? Well, you just figure out, you come up with some answer that looks plausible. And regarding the applications, the coding applications, that means if we state the problem vaguely or ambiguously, the LLM by itself would not come back to us and say, hey, this is plain wrong, right? Please tell me more about that. It won't ask you the clarification question. It will just start generating code if you just, build the naive coding agent. So this problem is also with us because of the way the models have been trained. At the reinforcement learning stage, we just train the model to pick up the best out of multiple options. Like if you have multiple implementations of the same function, you can rank them and you can train the model to come up with the better implementation more often than with the worst one, but that doesn't change the implications and consequences for us. So they're still with us. Now, a few words about the agentic systems and what are they. At the very early days of ChatGPT, people noticed that you can kind of state your question like that. You're presented with the user request and the function. Functions, in plurals. Your task is to respond with the function name that should be used to complete this task, or none if no function is required. Request: what is the weather in Durham today? Functions: get time, get weather, get currency. And the model will give you something like get weather. This is the actual execution of the modern ChatGPT, so we can still do that. Gee, said people, that's fun. You can actually make the model to select the function, so you can present the model with the external functions, and the model will figure out which one to call to help it to execute the task. So at some point, people just internalize that with the LLMs by introducing separate tags and structures, because the model only works with the text, allowing the model to put those function calls into separate structures so that we can parse these structures and actually execute these functions. So effectively, the agent is the LLM with the tools, and that's about it. When you have your agent, your coding agent that does stuff to your code or to your infrastructure by calling the bash command, the actual under the hood situation goes like that. The LLM generates the name of the function and the input parameter of the function, and then your agent, such as Claude Code, executes the call. So the LLM just provides the instructions, the actual execution, and the safety, the guardrails, and other stuff. So not to do RM minus RF, that fun joke, right? So it often belongs to Claude Code itself or any other agent. All right. So far, so good. So these were the agents. The fun stuff of the agents and the functions is that you can execute anything you like. The agent, just the tool, the LLM rather, provides you with the name of the tool and the parameters. The execution belongs completely to your own code, and your code could execute whatever you like. So with the tools, you can do such things like RESTful APIs, database queries, code execution, any other function, bash calls, bash scripting, because these executions were executed by your custom code, not by the LLM. And LLM just provides the instructions. So it's a wonderful pairing, wonderful abstractions and team play, if you will, between the LLM that generates the details of what needs to be executed and your code, which you can own if you need to, that actually knows how to execute what LLM wants you to execute. That's how that's essentially what makes those agents powerful, right? It's not just the LLM; it is also the code that executes those functions. Good. Key issues with machine learning LLMs and agents. So, data bias problem. Remember that we trained the model to predict the next word based on the internet data. What that means for us practically? That means, well, the model will be better with what's popular online, and the model will be worse with what's not so popular. For us, the implication, for engineers, the implication goes like that. If you are using an unknown or marginal language or technology stack, the model will underperform on this language as compared to the popular language. That's why all those models were and still are much, much better with Python than, say, with Erlang or with something of a Fortran or something of a similar caliber. The internet just has much, much more better Python data than Erlang or Fortran. Oh, if you are using an in-house technology that the internet knows nothing about, then the LMs will underperform with your in-house technology by design. There's nothing you can do about it. I mean, you can, but you need to extend the LLM. There's nothing you can do in the LLM itself to fix this. Or if you're working in an emerging industry, the LLMs have the knowledge cut-offs, meaning the LLM has actually been trained on the data gathered online at some point in time, and the LLM doesn't know anything that happened after this moment, right? And if the technology you're working with emerged or matured after this date, the model naturally will underperform with this technology because, well, the model hasn't been around, training hasn't been performed on this more recent information as compared to the old information. Since we are building a lot of, say, agentic systems, we hit that constantly. These LLM and the models and the tools, the coding tools, they're much better with, say, API development as compared to the agentic development. Why? Well, because all these agentic frameworks, they are very recent technologies. And most often, most likely, your model hasn't been trained on the data that involves enough of the information about this agentic framework. Not to mention that this agentic framework will be still marginal in the whole vast amount of the internet data as compared to building your endpoints. So what you can do about it? Instead of relying on the internal model knowledge, you could and should substitute it or supplement it with the search. Which means if you are working in emerging industry or with an in-house technology or with unknown or marginal language or technology stack, force your coding agent to always execute the web search, regardless of whether the agent thinks it needs to do that or not. Just force it to do it always or most of the time, because by executing the web search and gathering the up-to-date information from the web, the agent actually learns something about your emerging agentic stack, for example. Or by executing the internal search, the agent gets the information about your in-house technology. So you got the idea. Instead of relying on the model knowing something about one of these, right? You force the model to get this information from the search and pass this information as an input, so that the model might not know much about it internally, but you provide this information as an input. Next, the bad token problem. I already told you about it, being a little bit ahead of myself. So that's the situation with the French capital because of its importance to the French people, right? The model will generate rubbish and occasionally, but when it does, it tries to make this rubbish plausible by, well, introducing this rubbish into your execution, into your infrastructure, into the things where the rubbish doesn't really belong. What you can do about it? Well, you can review that with the human in the loop, obviously, but you can dramatically improve the situation with the bad token by reviewing the solution with another LLM, because the bad token problem applies only to the output. So the model would only try to make the output plausible and not the input. If you ask whether the French capital is known, whether French is known as a French capital because of its importance to the French as an input, the model would be perfectly comfortable with telling you that's rubbish. And that's what we need to utilize. We can pass the output of one model into another model or even into the same model because the models are stateless, right? And ask it to, well, provide critical feedback. And then you can ask your primary model to maybe edit your result, your code, your documentation or system design based on this feedback. That helps dramatically. The always answer problem. The model trained on question answer pairs does two things. It never asks questions and it always provides answers. What we can do about it? We can explicitly instruct the model to ask questions. That's kind of fun and kind of ridiculous, but it works. If you instruct the model explicitly, ask clarify the question, clarify any ambiguous points you might see, or validate your design with the user. The model actually does that, but only if you state it explicitly. It won't do that inherently. And even if you see this behavior in something like Claude Code, if you trace the what goes into the LLM, what Claude Code actually sends to the LLM, you'll see that this statement is there, right? So actually, that's the way to overcome this problem of the always answer situation. Great. The next thing, MCP servers and skills. What are they? How we can use them? I already mentioned you a couple of things about fixing the LLM and agent coding problems, right? I said things like use web search. Okay, but how do I force my agent to use the web search, right? Or I said things like force or rather use another LLM to review the outcome of your agent. Okay, but how do I do that? Here we need MCP servers and skills. So what are they? The MCP server contains the name MCP server contains two parts, the MCP and the server. And they are complementary but completely different animals. MCP stands for Model Context Protocol, and it is just a convenient way to introduce your tools to your model. Before the MCP protocol standard, which is very recent, has been introduced in December 2024, so roughly 15, how many months ago? Year and a half ago. Before that, we had to inject every individual tool into every individual LLM by adjusting those tags, stuff like that. Doable, but not very enjoyable. With the MCP, if the model supports the MCP, you could just introduce or add or, well, inject, whatever definition you prefer, your tools into any LLM of your choice. So suddenly it becomes an interface, the unified interface, the USB of the agents, if you will, that allows you to connect any tool to any LLM. But as I already mentioned, the LLM only names the tool and something needs to execute it. Here comes the server part. The server is a custom code that actually executes the function. Now, when you install the MCP server to your agent, to your coding agent, it brings along some of the tools, some number of tools. And this is a real example of the GitHub MCP server, the official one. It brings along more than 40 different tools. And these are the actual tools, right? Create repository, fork repository, create branch, and so on and so forth. Now, if you install a couple of those MCP servers, then your agent could easily end up with 150 or 200 tools, easily. How does your agent know when to use which tool? If you just leave it be and hope that your agent would figure out when to use each of those tools, you would end up with the agent that does nothing. So if you just install a bunch of MCP servers to your coding agent, say Claude Code, and you expect Claude Code to figure out on its own how to navigate across those tools, well, it's not gonna fly. Here comes skills. Skills are workflows, essentially, and these workflows allow you to specifically instruct your agent what to do, which steps to take to execute a particular task. You can do that with the prompt, naturally, but, carrying along and copy-pasting large prompts is unnecessary and suboptimal, perhaps. So in the December 2025, which has been 5 months ago, Anthropic introduced skills. Skills are another protocol akin to MCP, but skills are the workflow builders or the workflow definitions, if you will. And a part of this workflow could be a specific tool that the agent needs to execute. So for example, if you are building or designing skill for merging the upstream repository change and resolving the merge conflicts, you can actually name specific tools which the agent needs to call at the necessary stages of the execution. This way you overcome this tool clutter situation when your agent has 200 tools without any idea when to use them. So the skills are workflows that guide your agents through the tools. Good. To illustrate you, to provide you with the example about how that actually works, I came up with the simple scenario. Suppose you want to create a GitHub app and you're working with whatever agent you prefer. That applies to Claude Code, to GitHub Copilot, to Codex, to all of them virtually. You could start like that. You can say, create a GitHub app that will trigger a webhook when there is a new commit. So far, so good, but please don't do that. You can do much, much better than that. One simple way to improve the situation would be to provide a context into your repository. Suppose you're working in a monorepo, in a large monorepository. Nice thing to have would be pointing out your agent at the specific implementation of the webhook, right? So now it knows that it needs to look at this location to see the implementation of the webhook that needs to be triggered. And also you can point at the place where the GitHub app should be implemented. That's better. But in this setup, you still rely on the agent knowing how to implement a GitHub app. Maybe it knows, maybe it doesn't. So you can extend it even further. You can go to your favorite conversation chatbot. Gemini is particularly good at that because it is connected to Google search index. And you can ask it to do a deep research on how to build the GitHub app. You can literally say like, run deep research on the best practices for building GitHub app with this particular language or with this particular technology stack. And leave it be for 5 minutes or so. It will prepare you a report. You can copy this report or rather export this report as a markdown file. And you can paste it into your repository into a folder that I like to call .research, but that's my preference. You can call it whatever you like. You just dump all your deep researches into this folder, and then you point your agent to these reports so that your agent could actually learn how to build the GitHub app without relying on the internal knowledge. As you can see, there's a pattern in what I'm telling you, and the pattern is kind of don't rely on the internal knowledge, never rely on your LLM, right? Supply as much context as you could so that it can absolutely do no wrong. Okay, so far so good, but you can go further. I mentioned that the question answer problem, always answer problem, means that, well, the model could take assumptions without clarifying them with you, or if something is unclear on the, say, system design stage or requirement stage, the model will just assume something. Should this app be accessed by a particular user, by any user? What access rights should this app have? Lots of questions. And it is important for the agent to clarify these questions with you since you are building this app. So we'd like to inject things like if any of the requirements are unclear or ambiguous, ask the user for clarification. Make sure every design decision you take is supported either by the requirements or explicitly confirmed by the user. Good, now we've fixed the always answer problem. But we shouldn't stop here. We can specify the exact execution. We can say something like this: follow this approach step by step. Write requirements MD file before you start your work on a new task and review it with the user. We can also specify what this file should be about, such as sections. As is section to B section, separate subsections, rules, acceptance criteria, test details, yada yada. Second, use web search to get up-to-date documentation and information on packages, functions, APIs, and other technologies you plan to use. That fixes this data bias problem. As I mentioned, you want to force the model, force your agent to rely on the web search or the internal search results rather than the internal knowledge. That compensates for lots of problems and improves the quality by a lot. Then you say proceed to the implementation. Follow the implementation plan outlined in the requirements MD. Implement one small change at a time, apply, build unit tests, follow the test-driven development practices, everything you like. So that's a comprehensive prompt, and the agent is likely to do a good job. But do you really want to copy and paste it to every task definition every day, multiple times? You don't have to. You can take this whole yellow section and convert it into a skill. Now, if you use Codex, then you can substitute this entire section with the use skill clause. Or that's Codex, right? My skill, okay. If you use GitHub Copilot, that would be /my skill. The definition is very similar, it's just the way you invoke the skill. Saves tons of time. You can have different workflows for different tasks and you invoke them separately and knowingly so that you know which workflow you want the system to follow because you designed it. So these are skills, that's how they're useful, and that's how they allow you to solve all these problems. So how do you force your agent to use the web search? Well, you install the web search MCP, and you have a skill that forces it to use this MCP and the web search tool. Now we have our own favorite setup, which we like in particular. This setup solves lots of these problems, pretty much every problem that I mentioned, and based on the feedback from the market, from the customers, and from the internal experiments, this setup improves Claude Code generation quality by 20%. We are quite proud of it because Claude Code is a wonderful product by itself. Anthropic puts a lot into Claude Code code quality generation, and 20% boost is a big deal here. All this setup is completely free and open source, so you don't have to pay anything. You can install it yourself. Everything is on GitHub. So what do we have here? We have Serena. Serena is a headless IDE. An important responsibility of the IDE is keeping an index of your repository so that you can control-click on the function or the class and you end up with the package that implements this class. Without this feature, your agent would be limited to using search. So you need to run the search across all the code base, then the search brings you up something, then you need to figure out what's there. Serena builds this index that allows your agent to look for where this function or class or method or whatever is implemented. That's one way. And the other way, if you have the class or method at hand, then Serena allows your agent to see where it is used. Saves tons of tokens, saves tons of effort for your agent, and very useful in itself. But also, Serena allows your agent to record memories. Without the memories, for your agent, every day is a new day. You come to your office in the morning or to your desk if you work from home, you launch your Claude Code or GitHub Copilot, and you need to explain it every context, the project context and your own individual kind of preferences and design decisions from scratch every morning. Well, you can maybe put that into the file and then you can just say, read this file, right? But that also means you need to manage this file by yourself. It's not very convenient. Serena allows your agent to save memories, and you can commit those memories to the repository. The memories are saved in the .serena folder in your repository. You can git ignore it, or you can commit it to the repository. And if you commit these memories to the repository, then suddenly the memories of your agent become available to all the other agents out there. So your teammates could share memories with your agents, or the front-end team's agents could share memories with the back-end team's agents. And that's, you hope you see how cool is that, right? Now suddenly you're working, say, on the front-end part, and now your agent knows about the back-end design decisions made weeks ago, and it could adjust your implementation to these decisions. And by the way, we are not affiliated with Serena in any way, right? We just love to share great tools and setup with you. Super. Next, kindly web search. The web search, the default web search with those coding tools, and also the generally speaking, the MCP service is very broken in the sense that your default MCP server for the web search would allow your agent to, well, run the web search. And what the web search brings you back, the URL. And that's it, maybe a snippet. But then, when we are searching as engineers, we actually want to, and we are likely to end up in the place like Stack Overflow or GitHub issues, and we want to read the conversation. We want to read things like, I tried this one, it didn't work for me because of the setup, the environment, this version of this library failed in this environment, so you need to install maybe the previous version. Well, if you've been there, you know what I'm talking about. And when the MCP server just brings back a URL that is not very helpful. Kindly has been built for the development, for the coding agents specifically, and it brings all these conversations specifically from Stack Overflow, from GitHub issues, from GitHub conversations, other places, via the API, scraped via the API, not by the browser scraping or whatever, although it has the browser fallback. But these conversations from Stack Overflow and GitHub issues particularly, they're nicely structured in Markdown. They preserve all the metadata, such as this bring checkbox, meaning that's the correct answer, all the threads and branches. So it just makes this whole information specifically from Stack Overflow and GitHub issues that come to you via the web search accessible for your agent. LED is the MCP server that allows the other LLM look at what your LLM generates and provide the feedback. And also LED integrates with Serena. So that other LLM that reviews whatever your LLM or your agent generates also has access to all those memories. So LED cannot just spot the logical fallacy. There's almost none these days. But LED can spot things like, well, your implementation contradicts the design decision taken 1 month ago by the backend team, for example. Or LED could spot things like your implementation doesn't fit the requirements that some other team recorded into Serena memories two months ago when the project started. So that's pretty cool when the LLM could spot these kind of discrepancies. And finally, there's a skill, sort of one skill to rule them all, and that's the agent skill TDD. That stands for test-driven development. And as you see from all this conversation, from all this long journey with me today, what seems to be, so when you look at the Claude code, you might think, well, it's simple, it's easy, right? It is much like maybe Notion or say Slack. You can throw that to your engineering team and they will figure. So you just, set up your Notion account or your Slack account, your engineers, they figure it out. But hopefully, after all this conversation, you kind of get the flavor. I would argue that all these tools like Claude Code, GitHub Copilot, Codex, they are more like Microsoft Dynamics CRM and less like Notion. You would never throw Microsoft Dynamics CRM to your sales team expecting them to figure it out or use it properly. Or if you do, then it won't end well, right? Probably they would hate it. So, so Claude Code sits at best in between. You still can throw Claude Code at your engineers, hoping that they would figure, and they would figure it to an extent. But pretty much like Microsoft Dynamics CRM, Claude Code really shines, and that applies not just to Claude Code, any agent. Think GitHub Copilot, then Codex, others. They really shine if you configure them and set it up properly for your own company and for your own individual team, connecting to the proper MCPs, building proper skills. that's when they start bringing real value. And at the end, to conclude our conversation before proceeding to the Q&A, I'd like to ask you the final question. After today's session, what's the first thing you want to do differently with AI coding tools on your team? And we have a couple of options for you. Please take your time to check all the boxes you'd like to check. And I guess we're good. My dear friends and colleagues, please show me what you got. Aha, that's very interesting. 78% say that they would like to rework how we give AI tools context, which is pretty cool because the context is a king. All these tools, the whole intelligence of the model is all smoke and mirrors. The, they really shine in crunching data, in crunching context. You shouldn't rely on the intelligence. So yes, reworking how you give the AI tools context is very reasonable. Thanks a lot. Thanks for being here today, and it's time for the questions. Let me see whether we have any in the Q&A. So just to remind you that we have a Q&A section out there somewhere on the top or the bottom, depending on whether you use full screen or whether you're not. So if you click Q&A, you'll be able to ask questions. Okay, I'm going to go through these questions one by one, as long as we have them. So I have the first one, which is to reduce hallucinations and poor code-based understanding. What delivers the fastest improvement? Better context grounding, stricter tests, or agentic workflows? Okay, so hallucinations and poor code-based understanding. Indexing definitely works. So Serena is your friend if you need to, if you work with large mono repos and you struggle with the agent not understanding the code base. And so installing Serena is something you can do like in 30 seconds and would immediately boost your agent. Context grounding also helps. So it would be nice to have a, say, markdown file somewhere in your repo explaining what this repo is about to the agent, especially if the repo is large, right? So if you are working on large, I don't know, open source, closed source projects, millions lines of code, then just explaining the system, what's there is important. You shouldn't expect it to figure it out on yourself. I would not vote for the tests as the way to address that. And the workflows are very powerful in this setup. They won't help with the hallucinations and code-based understanding. Instead, they would help the model to do the work done regardless of the code-based understanding. So even if the code-based understanding is imperfect, the right skill could still push the model and the agent towards the right things, even despite the agent doesn't understanding the code base really well. So this one is done, and I invite you to the next one. The next one comes like this. If a team has to choose between Copilot, Cursor, Windsurf, Claude Code, or Codex, what's the simplest rule to decide? There's no simple rule, and one thing you should keep in mind is the cost. These tools could be very different in terms of the pricing. So I'd say that Copilot, Cursor, Claude Code, and Codex, I didn't touch Windsurf for a while, so I'm not sure about them. But at least these, Copilot, Cursor, Claude Code, and Codex, they are pretty much on par, but the pricing is very different for them. So you need to see what works best for you and what fits best your budget. The next question is, recommend KPI for a starting point on metrics. Well, I'm kind of big fan of DORA metrics. You know, those DORA metrics like the deployment frequency, the other things, and also we have the space framework, so you can combine them. The beauty of DORA metrics and space framework is that you need to kind of have those metrics in tension with one another. So when someone tries to gain one metric, you will see the deterioration of another metric. It's like, for example, the deployment frequency and then the incident rate, right? You can, that's DORA, all that is DORA metrics. So you might want to have as much deployments and as little deployments as you can. Well, because if something goes off or wrong, it is just much easier to spot the problem if the deployment is like 5 lines of code and not 5,000 lines of code, right? So it's just much easier to figure things out. But you don't want people to push garbage into the production. So when you measure both things, deployment frequency and the incident rate, you can see that, well, if my deployment frequency goes up, but my incident rate goes down, that means we're just pushing garbage into production. So we need to test it better and not maybe deploy less frequently, but test things better. So I just want to point you at DORA metrics and space framework. And the combination of those two, I haven't seen anything better with respect to the engineering deployment and engineering general engineering metrics. Let's say this way. Okay, and I see no further questions. Oh no, I do have one. Okay, the next one is. You showed that real productivity gains can be much lower than benchmarks. That was on one of the slides. What 2 or 3 metrics would you recommend to measure AI impact realistically on private code bases? I would still point back at DORA metrics and space framework for arranging them. So say you adopt Claude Code or Codex or Cursor or whatever, and now you measure, say, the deployment frequency. I mean, I'm just keep pointing the deployment frequency and incident rate. DORA is a little bit wider than that, but let's stick to the simple examples. So you measure deployment frequency and incident rate. If you see that your deployment frequency increased and the incident rate stays steady, that's a good sign that your AI experiment or AI project succeeds. If you see that it didn't change, well, maybe you should take a look at how these tools were used and how they contribute, if any. So overall, I just want to shout out to DORA metrics and space framework once again for anyone who'd like to measure the impact of those tools on the day-to-day engineering work. And was that the last question? It seems to be, which means we are pretty much on time. Thank you very much for attending. Hope it was fun. Should you need any more time with us, please reach out to our dear friends and colleagues at the engagement by this email, following this email on your screen right now. Happy to talk to you should you have any further questions or should you be interested in how to apply those tools properly to your team or organization. And having that said, thank you very much. Have a good rest of the day.